Hi everyone, this is Paul Roman and I'm starting off our group presentation of a critique of the influence of various silvicultural treatments in forest operations on tree species biodiversity. The Latterini et al. Paper is a review focused on how different forest management practices affect the biodiversity of vascular plants within the forests they occur. Additionally, there is attention paid to how forest operation infrastructure, such as roads and skid trails, impacts the biodiversity of the forests they are built in. The idea was to gain a global perspective of how different silvicultural approaches can increase or decrease biodiversity within their target forests. The papers used for the review were selected through a keyword search in Scopus and Web of Science and were narrowed down to 56 papers published from 2013 to 2022. These papers covered a wide range of biogeographical zones across the globe, but most of the reviewed papers were from temperate and tropical zones. This figure from the paper does a great job highlighting how the reviewed papers were distributed and grouped. The forestry practices compared in the paper were selective logging, thinning, clear cuts, crop tree management, and coppicing. A separate section of the paper was devoted to comparing harvesting operations, or as they referenced it through the rest of the paper, forest operations. Two frequently referenced terms and concepts within the paper were sustainable forest management and sustainable forest operations. They were not defined within the paper, but the paper's references define them as following. Sustainable forest management is the process of managing permanent forest land to achieve one or more clearly specified objectives of management with regard to the production of a continuous flow of desired forest products and services, without undue reduction of its inherent values and future productivity, and without undue undesirable effects on the physical and social environment. Sustainable forest operations was defined as a complex system of relationships that encompasses a set of technologies, methods, systems, and practices applied in forest operations planning, implementation, monitoring, and improvement with the consideration of 5 performance areas. These 5 areas include the environment, ergonomics, economics, quality optimization, and people and the society.
Results. The main takeaway from this paper is all treatment types investigated can be used to maintain or increase the biodiversity of trees. This was especially the case if the treatment being applied was limited in scope and carried out with proper forest management. For selective logging, it was recommended for uneven-aged tropical forest stands, especially effective if the treated area was kept small to mimic natural disturbances, like the collapse and decomposition of a large tree. Thinning was most successful at maintaining biodiversity when the biomass removed was minimal. Keeping the scope limited led to retention of the current stand structure, while more extensive thinning led to a change in species composition. Clear cutting can have a mixed effect on biodiversity depending on the ecosystem where it is carried out. It is useful in increasing biodiversity in stagnant stands, but should be avoided in sensitive stands, like riparian areas. Coppicing was found to maintain tree biodiversity, but only with proper planning. If abandonment or short rotation practices ensued, biodiversity decreased. A well-organized network of forest operations infrastructure was critical for increasing biodiversity. Skid trails and landing areas saw an increase in biodiversity, but only if soil compaction and overall disturbance was kept to a minimum.
With those results in mind, it's important to acknowledge some of the ways that this paper fell short in its intent, along with some of the ways that it was still useful despite these shortcomings. Starting off with the weaknesses, the most immediate one was the lack of substantiative and actionable data. There were only 3 figures in this paper, and they only displayed the general focus of the collected articles and what environments they studied. For the actual analysis, no numbers or statistics were provided as to how effective each management type was, and instead, the authors provided general summaries of results from some of the papers. This created another problem where there wasn't any consistent comparison between the methods across different environments, and this would have significantly improved the applications of this paper's conclusions. The reason for this is seen in one of the 3 figures, and that is because there wasn't enough research in some of these environment types. While the authors do acknowledge this issue, it still created a pretty strong bias towards certain environments. Even with this bias, though, the inclusion of those outlier environments resulted in a very broad conclusion that limited the real-world application of this paper's research. With those weaknesses in mind, this paper still had some strengths that make it a beneficial read for land managers that are investigating potential management methods. To start off, this paper did a really good job of presenting its intent with clear language and well-defined subsections that had a clear focus throughout. It covered a wide variety of methods and environments, and the authors did a good job of breaking down those respective methods into subsections that gave the paper a flow that was very easy to follow. Even though, as I mentioned before, the suggestions can only be broadly applied, it was still very straightforward with the conclusion that all methods can increase biodiversity, but the best method depends entirely on what environment a land manager is working with, and they should always approach their investigation with that in mind. The final main strength was that their methods for gathering research articles related to this subject provided a really useful start for future research that investigates and provides a more in-depth analysis of the effects of each management type within each environment.
In conclusion, the authors of this review clearly gathered many papers to survey biodiversity in silvicultural systems. In forests where keeping present structure might be preferred, selective logging could be favorable to land managers because of its ability to facilitate biodiverse regeneration. In managed softwood forests, often those procured for productive timber harvests, thinning could be an effective tool to catalyze native hardwood regeneration. Implementing an organized system of forest roads could reduce soil compaction and disturbances on the ground to allow better vegetative and tree regeneration. And because results were varied among forest types in these papers, it's important to consider biogeography still when creating management plans. And still, this belief that managing for biodiversity can help guide silvicultural practices could be further integrated into mainstream forest management.